Hi everyone, I'm Zhou, a PhD student at Rutgers University Computer Science Department. Today I'm going to present our work called MIMU, Mobile Wi-Fi Usage Inference by Many Diverse User Behaviors. This is a joint work between Rutgers University and the Chinese Academy of Sciences. I will follow this outline to introduce our work. Let's start with the introduction first. Our work focuses on mobile Wi-Fi systems, which is essentially Wi-Fi on public transport. It is a beneficial service for multiple parties. For the riders, they can have convenient access to the internet. For the bus company, they can provide a better user experience to attract more users. And for the Wi-Fi service provider, they can cast ads to make profits. And there are two reasons why the prediction is important. The first is based on the bus Wi-Fi log data, we can do user profiling, which can then be used for ads, promotion, and recommendation. And the second reason is that we can do data traffic estimation. And essentially, we then can do data caching to save cost on the data traffic consumption for the bus Wi-Fi service provider. Our contributions are summarized here. We are the first to work on usage prediction of large-scale mobile Wi-Fi system, considering unbalanced usage distribution, also considering access irregularity and the mobility regularity. We then propose a two-dimension usage inference framework from user dimension and device dimension. We then have a spatial and temporal attention modeling for access irregularity and the mobility regularity. In the end, we did an evaluation on large-scale datasets with more than 110,000 users and more than 4,000 buses. We also discussed generalization, application, and privacy issues. For the model design part, in the beginning, we have the pre-processing module. Basically, we need to format the raw Wi-Fi log data into session-based data to fit into the prediction model. There are two submodels here. The first is user dimension submodel, and the second is device dimension submodel. Then we combine the two predictions here as the final content prediction. Then based on that, we can have content caching, location service, and the Wi-Fi sharing. Our problem is defined here. Given a device D, which is a bus Wi-Fi device, and the content C, the goal is to predict the bus Wi-Fi usage of content C on this device D, denoted by YDC. And the YDC can be approached by two parts. The first is the F function, denoted by the user dimension modeling. And the second is G function, represented by the device dimension. Those two models share similar structures, but with different inputs and different attention modules. So those two attention modules are actually dedicated versions of self-attention. For the temporal one, we consider high similarity for close timing and considering users taking bus at the regular time. And for the spatial one, we consider high similarity for close location. And for the same bus line, we also consider that certain locations can only be visited by certain buses. And the third part is about the evaluation result. We did our evaluation on the datasets with 2-month-long Wi-Fi log data. And we have more than 6,000 devices and more than 150,000 active daily users from 3 cities. And we show our results quantified by one metric, which is accuracy here. And we also show some results on factors like a day a week, data proportion, multiple city comparison. And we also have one caching application to show cost saving rate, hit and miss ratio. So this is the overall performance. We consider two significant baselines. One is neural collaborative filtering, one is deep spatial temporal residual network. And across all cases, our MIMU achieved the best performance compared to the baselines. And we also show the dimension ablation and show the performance in terms of day or week. And then we have the contextual investigation. Basically, we show the performance of MIMU in multiple cities, and we can see MIMU achieves the best performance in the largest city, Shenzhen, here in terms of accuracy. And we have the discussion and lessons learned here. So our work consider unbalanced usage dynamics, which are from two levels, the user level and the device level. And we also consider diverse usage participation, which are mobility regularity and access irregularity. We also have application and implication in terms of personalized modeling and profiling-based promotion. For more details, please check our papers. Thank you. And you can also check more about data and more related work on those two websites. Thank you.